set the stage. You're in a Java interview, the room is quiet, and the interviewer leans back, closes your resume, and asks a simple yet pivotal question. Can you explain immutability in Java? This isn't just a test of your memory or textbook knowledge. It's a moment that can shift the entire tone of the interview. The interviewer isn't looking for a robotic definition. They want to see how you think, reason, and communicate as an engineer. This is your chance to stand out, not just by what you know, but by how you explain it. Interviewer's question seems straightforward. What is an immutable object in Java? Many candidates rush to answer, thinking a textbook definition will suffice. But this is where the real test begins. The interviewer is not just checking if you know the term. They're evaluating your depth of understanding and your ability to communicate complex ideas simply. This is your opportunity to show clarity and confidence. Most candidates, myself included in earlier days, might reply, an immutable object is an object whose value cannot be changed. While technically correct, this answer often leaves the interviewer waiting for more. They want to see if you can go beyond the basics and truly understand what makes immutability important in Java. This is the moment to dig deeper and explain the concept in your own words. Interviewers don't ask about immutability just for the definition. They want to see how you think as an engineer. Your answer reveals your approach to problem solving, your grasp of Java fundamentals, and your ability to communicate clearly. It's not just about knowing what immutability is, but understanding why it matters and how it impacts real-world code. Let's break it down. An object is considered immutable if its state cannot change after it's created. This means that once you've built the object, none of its fields can be updated, and there are no hidden mutations lurking in the background. Immutability is a guarantee that the object remains constant throughout its lifetime. A key aspect of immutability is that once an object is created, none of its fields can be updated. This means that any attempt to change the state of the object will fail, either by design or by throwing an exception. This property is crucial for ensuring thread safety and predictability in your code. Immutability also means there are no hidden mutations. In other words, the object doesn't change behind the scenes. This is especially important in multi-threaded environments where unexpected changes can lead to bugs that are hard to track down. Immutability provides a layer of safety and reliability. Consider the string class in Java. Once you create a string, you can't change its value. Any operation that seems to modify a string actually creates a new string object. This is a classic example of immutability in action, and it's one of the reasons why strings are safe to use in multi-threaded applications. The immutability of strings in Java prevents unexpected changes and makes them thread-safe by default. This design choice means you can share string objects freely between threads without worrying about one thread modifying the value for another. It's a simple yet powerful feature that underpins much of Java's reliability. Besides string, Java provides other immutable classes like integer, long, and big decimal. These classes are designed so that their state cannot change after creation. This makes them safe to use in concurrent applications and helps avoid subtle bugs related to shared state. To create an immutable object in Java, you need to follow a few key rules. Make the class final, declare all fields as private and final, and don't provide any setters. If your class contains mutable objects, make defensive copies in constructors and accessors. These steps ensure that your object's state can't be changed after creation. Making your class final prevents other classes from extending it and potentially introducing mutability. This is a foundational step in ensuring your object remains truly immutable. It's a simple keyword, but it has a big impact on the integrity of your code. Declaring all fields as private and final means they can only be set once, during object construction. No other part of your code can change them later. This is a key principle in designing immutable objects and helps prevent accidental or intentional changes. By not providing setter methods, you ensure that the fields of your object cannot be changed after construction. This is a straightforward but essential rule for immutability. Without setters, your object's state remains locked in from the moment it's created. If your immutable class contains mutable objects, make defensive copies in constructors and accessors. This prevents callers from modifying the internal state of your object through references. Defensive copying is a best practice for maintaining true immutability. Immutability brings several benefits to your Java code. It makes your objects thread-safe by default, simplifies reasoning about code, and reduces the risk of bugs caused by unexpected changes. Immutable objects are easier to test, debug, and maintain, making your codebase more robust. One of the biggest advantages of immutability is thread safety. Since immutable objects can't change, you can share them freely between threads without worrying about synchronization. This leads to simpler, safer concurrent code and fewer headaches for developers. Immutable objects behave predictably because their state never changes. This makes it easier to understand, test, and debug your code. You don't have to worry about side effects or unexpected mutations, which leads to more reliable software. Debugging code that uses immutable objects is much simpler. Since the state doesn't change, you can easily track the flow of data and identify where things go wrong. This reduces the time spent hunting for elusive bugs and makes maintenance easier. Testing immutable objects is straightforward because their state is fixed. You can create test cases with confidence, knowing that the object won't change unexpectedly during the test. This leads to more reliable and repeatable tests. Many candidates stumble by giving only the textbook definition of immutability or by missing key implementation details. To impress your interviewer, go beyond the basics. Explain why immutability matters, how to implement it, and the benefits it brings to real-world Java applications. When answering questions about immutability, focus on demonstrating your understanding and thought process. Use examples, explain the reasoning behind design choices, and highlight the practical benefits. This approach shows that you're not just reciting facts, but truly grasp the concept. In real-world Java development, immutability is a powerful tool for building robust, maintainable applications. It helps prevent bugs, simplifies code, and makes your software more reliable. Understanding and applying immutability is a mark of a skilled engineer. Modern Java frameworks often encourage or require the use of immutable objects, especially in functional programming and concurrent environments. Familiarity with immutability will help you work more effectively with these frameworks and write safer, cleaner code. Java provides immutable collections through the collections, unmodifiable list, and similar methods. These collections cannot be modified after creation, providing the same benefits as immutable objects: thread safety, predictability, and easier debugging. While immutability has many advantages, it's not always the right choice. For objects that need to change state frequently, mutable objects may be more efficient. The key is to understand when immutability adds value and when it might introduce unnecessary complexity. To sum up, immutability in Java means creating objects whose state cannot change after creation. This is achieved by making classes final, fields private and final, and avoiding setters. Immutability brings thread safety, predictability, and easier testing and debugging to your code. By understanding and clearly explaining immutability, you demonstrate not just technical knowledge, but also the ability to communicate and reason about design choices. This is exactly what interviewers are looking for in a strong Java developer. The more you practice explaining concepts like immutability, the more confident and articulate you'll become in interviews. Use real-world examples, focus on clarity, and always connect your answer back to practical benefits. This approach will set you apart from other candidates. Immutability is more than just a buzzword in Java interviews. It's a core concept that underpins reliable, maintainable, and safe code. By mastering and articulating this topic, you not only ace the interview but also become a better engineer. Remember, it's not just what you know, but how you explain it that makes the difference.